Hi everyone, this is Group Beta. Here's our group members, Honghui, Jiajun, Qiqi, Yifan, and Yanu. Today our topic is about exploration data analysis and data modeling on New York City 311 service request. Next page. First, let me introduce our research background. As you know, 311 service request is a New York City institution which collected non-emergency city service data information. So our aim is using this data to explore and analyze some research question. Also, we will join another data set named Pluto, which is an open data source website and contains some buildings information and buildings geographic location information to help us answer another questions. This data set contains 1.2 million record and 42 variables. Since this data set is from the website, so we use API provided by the NYC Open Data website and import the data to the PySpark and manage and the analysis our data via PySpark. Here's 4 questions we put forward. The first question, we want to explore the most frequent complaint types and the most frequent complaints happens distribution. And the second question is exploring the most affected by the top 2 complaint type in the most complaint happened distribution. And the third question is about the relationship exploring between the building characters and the noise complaints in Berkeley. And also we use some predictive model to predict the noise complaints with key features of building characters. Next, please. The data preparation part is very important and initial part. Firstly, after scanning the whole data set, we found there are some variables contains a lot of missing values, more than 18%. And also this some of the columns are irrelevant to our analysis goals. And also they contain some useful information. So we drop these columns. And then we create our aim subsets to explore our to explore the virtualization. And also we change this columns name and types to the numerical and drop the missing value among them. Then we merge the Pluto dataset with 311 service request dataset by address. That is to predict if there's a complaint by building features. After merging this data, we found the target class is imbalanced. So we use mode method to oversample the minority class to have more than half numbers observation of the minority class. Then we use a random undersample method to under the samples the number of the instance in the minority class to match the same level with the minority class. Next, please.
Okay, hello everyone. About the first question, we studied the entire dataset. There are up to hundreds of different reasons for complaints. And this table shows the 20 of them with the highest number of complaints. The highest number of complaints was about illegal parking with a whopping 15,000 complaints. And the second highest number of complaints was about residential noise. The third highest reason for complaints is hot water. Based on the bar chart, we find that the agency receiving the highest number of these complaints is the New York Police Department, with the remaining agency receiving far fewer complaints than the New York Police Department. Next page, please. Based on the different about of New York, we calculate the number of complaints in different areas. According to this bar chart, we can see that Brooklyn has the highest number of complaints. The Bronx received the second highest number of the complaints after Brooklyn, where Staten Island has the lowest number of complaints. The Bronx and Queens has the smallest difference in the number of complaints. Next page, please. Now we will please Ethan to come to the second question.
So there is a higher density in this map. We can see our density of the parking complaints happens. There's a higher density of illegal parking complaints through downtown New York, which we suspect is because downtown New York is busier and has fewer parking spaces, resulting in a lot of illegal parkings. And we also see the number of complaints was higher in Western Queens, where illegal parking is an ever bigger problem in Manhattan. Which is the economic and tourist center of the New York, with many vehicles but few parking spaces, hence the higher concentration of illegal parking complaints. The southern west part of the Bronx has a higher number of illegal parking complaints, where the northwest part of Brooklyn has a higher concentration of illegal parking. Next, please. The Manhattan residents' noise problem is concentrated in north part of the borough, because Midtown and Lower Manhattan are economic center with fewer resident area. Residential noise mainly occurred in northeastern areas. And Bronx resident noise complaints are concentrated in the southwest. For the most part, Brooklyn residential areas is noise concentrated in the northeast, where noise complaints for Queens resident avenues are intensified in also in northeast.
Hi everyone, this part is to answer the question 3, which is the relationship between the building characters and the complaints of noise complaint. Table on left shows the result of Pearson's correlation, which is used to measure the linear correlation. We find that there is no strong or moderate correlation between features and the number of residential noise complaints. Table on right shows the result of Spearman's correlation. Similarly, there are some weak positive correlations between features and the number of residential noise complaints. Next page, thanks. In order to check whether the correlation between features and the number of residential noise complaints is statistically significant, we calculate the p-value of features with the number of residential noise complaints. We could find that even though there are some features whose p-value is very low, the correlations between they and the residential noise complaints are so weak. Next page, thanks. This chart shows the correlation between every pair of features and the number of residential noise complaints. We could find a strong positive correlation about 0.8 between the number of residential noise complaints and the combo of the maximum allowable residential floor area ratio and the maximum allowable community facility floor area ratio. So I could guess that with more allowed floor area for residential and for the facilities, it's more possible to make noise and more possible complaint by neighborhoods. Next page, thanks.
Okay, now here's the part about the data modeling. And since we have discovered some key features in the correlation exploration, and so we assigned the complaint as the target variable and some key features as the independent variables. And for the independent variables, here are some residential area, number of floors, building total area, and also some building depths. But we also found the target class extremely imbalanced, that only 2% of the records have the complaint records. So we used the mode and the random sampler to balance the target class. And from the result, we can see after the resampling, the target set has the two class in the target variable is in the same level. And so we built two models. One is the random forest and another one is the XGBoost. The random forest is a bagging-based algorithm where only a subset of random features are collected to build a collection of decision trees, while XGBoost is optimized gradient boosting algorithm that through parallel processing and handling massing values and also regularizing, and also have the regularizations to avoid overfitting. From this two result plot, and we can see both models have a nice accuracy on predicting the noise complaint. And for the random forest model, it has around 80% accuracy, and for the XGBoost is higher than the random forest, which has the around 92% accuracy. And also from the random forest and XGBoost classifier plot, they are showing that our data sets not overfitting. And this RC curve and shows XGBoost had a better performance than the random forest, and the accuracy on the XGBoost is also like higher than the random forest. And since the classification model is not like the regression model, we can see some negative or positive coefficients. In the classification model, we often use the important features to identify what's the most important features. And from the result above in the slide, we can see the facility. The facility floor is the most important feature for both classification years, and moreover, the features like residential, like the residential maximum allowed area or the number of floors and residential area rank very high in the importance. And in the whole project, we have encountered lots of issues and problems, and also we spend lots of time to solve them. The first problem we have met is the data set. Yeah, the requirement for the final project for the amount of data is more than 1 million. So we found this 311 servers request, and to handle those large amounts of data, first we tried to use the Databricks community edition to execute some commands, which we tried because we have done some practice in the past weeks, and it's really convenient to visualize some data. But however, the community edition only allows us to import data, not allowed us to import data over 2 GB. So after numerous trials and errors, we decided to turn our site to the Python by using the PySpark to process those data. And PySpark is a very nice library that contains like some Sparks SQL functions and also some machine learning algorithms. After we answer question 1 and question 2, we found some like interesting things is that because we don't have a car, but we do have to rent a house to live. So we decided to put our focus on the noise residential prediction. And the first step we did is to find a correlation between building characteristics with the noise complaint. But however, most of the features are not linear correlated with the noise complaint, but we did find some like relevant features. So in the data modeling part, we selected those important features and added some feature that we think might be helpful to the model performance. And the result turns out that both XGBoost model and the random forest model have a very nice performance on predicting the noise complaint. Yeah. In the conclusion part, we can see the top 2 frequent complaint types are illegal parking and residential noise. And the number of illegal parking in Berkeley is the highest compared to the other boroughs. And from the July 2022 to December 2022, the New York Police Department have received the highest number of complaints. And yeah, as I stated before, the building features are not, most building features are not linear correlated with residential noise. And our random forest model as XGBoost model perform well on predicting noise complaint. Yeah. And for some feature in the importance, feature importance, the residential allowment area, maximum allowed area, number of floors, and the residential area ranked high importance. And our XGBoost has like a 94% accuracy, which is higher than that of random forest model with 81.40% accuracy. Yeah. And here's our reference, Jensen Brownlee, which is one of my favorite like content creator in machine learning. And thanks for listening. If you have any questions, please free ask. Yeah.